Hello, everyone. Welcome to our third week of discussions on big data at Comcast. This week, we'll be discussing the ETL design process as well as our dimensional model used for our ML voice team. My name is Sean Reynolds. Let's get started. This is an overview of what we will be discussing, specific to how a static database can assist our machine learning efforts and assist our data scientists in post-production analysis using an ETL database. As a review, ETL stands for extract, transform, and load, and it's the process of how data gets cleansed and then loaded into a data mart for further analysis using a BI tool. In this brief discussion, we'll also discuss the setup of daily batch loads for our downstream analysts. And finally, we'll discuss the chosen ETL tool, Amazon Redshift, and some of the other modeling tools within AWS that allow us to meet our EDM requirements discussed in the previous weeks. This next slide is where we'll spend a bulk of our time. This is the ETL modeling process as described by Kimball in 10 steps. Over to the left, we have an overview of the entire ETL process where the source systems lie in green, how the information is extracted using the ETL process in orange, and then loaded into the data warehouses or data marts in pink. The first step of the ETL modeling process is to draw a high-level plan. The plan goes over details of the ETL process, such as the originating sources, how those sources will target repositories, mapping those sources, and then targeting repositories in the data warehouse. After the plan is mapped out, the second step is to choose an ETL tool. In this case, we're going to discuss Amazon Redshift. The data warehouse, highlighted in pink in Figure 1, allows business users and data scientists to increase ML model efficiency using cleansed data. After we selected an ETL vendor, our team has found a promising case for Amazon's Redshift due to our inherent use of Amazon S3 storage and the ability for Redshift to allow exports and queries from our existing data lakes. We'll talk more about Amazon Redshift in another slide. Our third step in ETL modeling is to document where information that is returned is housed in our warehouse and all of the possible ways that data can be used in OLAP analysis. We then set up and organize how data is staged and stored for archiving and recovery. After step 4 is complete, which is to drill down by the target table, we will then finish by documenting and describing the table's design, the load frequency, and detail all the source to target mapping and other critical dependencies and logic. Because the fifth and the sixth step of the ETL plan are closely related, most of the same processes and functionality can be reused. Let's take a look at a sample dimension in the next slide for the program or show dimension. Each dimension is loaded historically with the surrogate keys linking back to a fact table. In Figure 2, that would be the customer action facts. In step 6, we will load fact table extracts, tying back to any operational systems via a source code that identifies the origin of the data. It's important here, as shown in Figure 2, the customer action ID is expressed in the same grain as the rest of the customer actions. In the seventh step to the ETL process, we will load incremental dimension table data. The historic data load is mostly made up of inserted rows, and incremental data load is made up of updated and deleted rows. As new facts are added, in this case, customers, the eighth step of ETL guides our DBAs on how to add or make updates since the previous load. In step 9, data is aggregated into an aggregate table, keeping aggregations in sync with the underlying fact table. And then the final step of ETL is to schedule when your jobs will happen, usually in our case, overnight. Let's next go back and take a look at our example dimension model. The first thing we want to illustrate here are the customer action facts table. and how that would be updated in incremental loads. These type of loads are also known as type 3 changes, which are types of slowly changing dimensions that require a new column being added to the dimension table, or in the case of metadata information, updating tags such as the main genre or ranking of a program. It's important that before the loading phase, we choose strong surrogate keys, and that our surrogate key design helps to increase the referential integrity. Having a strong record of surrogate keys will help to ensure there's a good delineation or sequence to the natural keys of program titles that might include things like episodes or sequels. In the next slide, a few things to touch on Amazon Redshift. A few things to point out: Amazon Redshift allows for deep integration with our data lake and other AWS services, as we discussed. Another important factor is the use of pre-computed results to run faster materialized views. And advanced data governance features will allow us to give access to any cluster without having to move or copy. In addition to apps for data visualization, Amazon SageMaker specifically is a machine learning app that can help Comcast to automate data labeling and lower our inference costs. Through the course of the last couple of weeks, our team has presented high-level insights into the strategies and decisions surrounding EDM technology. Amazon Redshift is a viable solution for us to establish sound ETL practices that can improve our data governance and collaboration with downstream BI users.